Hello, welcome back. We're on page number 116 in your science book, and you have your journal out. Excuse me, I had to get some unsweet tea. I'm sorry I can't be with you today, but I hope you're having a good day. I hope you have a great week. You feel free to email me anytime, maybe from your device or from a computer at home. Perhaps you can email me and I will answer you as soon as I can if you have a question about something. We're talking about energy today, reviewing. Energy is the ability to do work. Without energy, nothing works. Everything needs energy. Forms of energy. Man, it's been a while since we've looked at these. We have electrical energy, thermal energy, sound energy, we don't need to know kinetic energy in 5th grade, so we'll skip on down to light energy. We don't have to worry about potential energy in 5th grade either. So let's go back to electrical energy. It's caused by the movement of electrically charged particles. When you use the toaster, you're using electrical energy. Metals are good conductors of electricity. Movement of electrons. Metals are good conductors. Thermal energy. Remember, you can push pause anytime you need to. Thermal energy is just another word for heat. For thermal, metals are good conductors. Also, sound energy is created by vibrations. Light energy travels as waves. Usually light energy is either being refracted or reflected. We can skip those pages. Here's a little bit more on thermal energy. If you'd like to read more about thermal energy, you can read about it right there. This is a great place to sort these good thermal conductors and poor thermal conductors. If it's a poor thermal conductor, another word for poor thermal conductor would be, an insulator. So in your book, you can go ahead and write down where wood belongs, where does steel go, plastic, air, rubber, glass, and copper. Why don't you push pause and write those down for a minute. So there's my answers. You don't have to write these two in your journal. You really should already know this, plus you wrote it in your book. But the only two good conductors I see are going to be the two metals, steel and copper. Everything else, wood, plastic, air, rubber, glass, those are all going to be insulators or poor conductors. Let's go on over to number 126. Sound. Here's some more information about sound, a vibration. If you want to read more about it, you can read about it right here. How sound behaves. You don't have to understand all this, but it's interesting to read about the pitch, about the volume. A decibel is the word right here. Here's the tuning forks like y'all used back in 4th grade. I believe y'all used tuning forks in the lab last year. And let's go on over to page 134, how light travels. There's some extra words we're going to write down over here. That's a shame. There you go. How light travels. Light can pass through some materials and not others. Transparent materials let nearly all light pass through them. If it's transparent, light passes through. Translucent materials. Glass and air are examples of transparent. Almost all light goes through glass. Almost all light goes through air. Those are transparent. Translucent, on the other hand, these materials allow some light to pass through, but not all, such as wax paper, and most lampshades are translucent. So some light can pass through. Wax paper is an example of this one. Lampshades. If you think about a lamp, I don't see one in my room, no, but lampshades, maybe you have some lamps at your house. They keep the brightest light from coming at your eyes, but they allow light to go through. You know, I guess those coverings on the lights on the ceiling, those are kind of like lampshades. If we were to open up one of those lights on the ceiling, there's a lot more light in there, but the shaded part keeps some of it away. So the light shade up there, that would be translucent. Opaque materials do not let any light pass through. So like wood and metal, those are usually opaque. There's not a lot of light passing through the metal on your chair. There's not a lot of light passing through the wooden desks. No, those are opaque. So these are words I don't think you have to totally know for 5th grade, but it won't hurt you to learn. I'm sure the 6th grade teachers will like it if you already know transparent, translucent, and opaque. And there's some good examples in your book right there also. Reflection. We already know about reflection. Reflection is when light bounces. We won't put back because it doesn't always have to bounce back. When light hits an object, some light is reflected. Reflection happens when light bounces off of an object. The light still moves in a straight line, but goes in a different direction. Well, there's a good one. Light always travels in a straight line. Refraction. Refraction is not the same. Refraction is when light bends. But you just said Mr. Haase travels in a straight line. It does travel in a straight line until it hits a mirror, and then it bounces back in a straight line, or until it hits something like a lens, and then it gets bent, and then it keeps going in a straight line. So you can see the straight line coming toward the lens. When it goes through the lens, it bends, and when it comes out, it continues to go in that new straight line right there. So refraction is the bending of the light. Reflection is the bouncing of the light. I like this part right here. Classify it. Look around the classroom. Which objects reflect and which refract? Fill out the table below with your findings. So there's probably several objects in this classroom, such as the shiny metal on your stools and chairs. Is that refracting or reflecting? So right here we put shiny metal, and the answer should be, yeah, that's right, reflecting. Is there anything refracting around here? Okay, well, y'all write that down. It's kind of hard for me to hear you where I am, so I'll just assume that you're getting it right. You should know that there's a difference between reflection and refraction. If you need to push pause and write some more down, you can. Maybe some that aren't in the classroom, you can just write the ones from the book. Here's some reflection in some glasses. Here's reflecting off of a mirror. Refraction is going to be in a lens, and you already know other refractions. I can write some down for you. Microscope, telescope, reading glasses, lens, hand lens. That's right, prism. A rainbow is an example of one. So there's a few things. Doesn't like my rainbow. And rainbow. This is stuff, I think Mr. Rojo went over this a little bit with you. You don't have to know all this in 5th grade. It's interesting to know about light waves and color, the distance between the crest of the wave. So different lights have different wavelengths, which causes the electromagnetic spectrum. You don't have to know this for 5th grade. If you'd like to know more, here's those 2 pages you could read about. Optical instruments. So here we go. Here's some more refraction happening here. Here's a great example of the prism. The white light is coming in straight. It gets bent in the prism, and now it leaves straight, but it leaves at different wavelengths because of the different colors of the rainbow. Here's an example of the telescope. You look through the telescope and it makes the stars and comets that are really far away appear close up. So it's got lenses in the telescope that bend the light, making it seem closer than it really is. Okay, let's head on over. We'll skip that one. Ooh, electricity. Page number 146. Uses of electrical energy. So we can transform it from one form to another. Transform. Changing energy from one form to another. Is that we're going to use it right here. An electric circuit is a loop that allows electrical energy to transform into another energy. Here's our word conductor, insulator. And here's one we haven't really talked about, a resistor. A material through which an electrical charge cannot move easily is called a resistor because it resists. As current moves through a resistor, some of the electrical energy changes to thermal energy. We can eat toasted bread because of resistors. In toasters, wires of nickel and chromium resist electrical current and turn electrical energy into thermal energy. Under most conditions, all materials, including copper and gold, have at least a little resistance. So there's a little bit about the resistor. I don't think we're going to have to write that one down, but we definitely need to write down conductor. Allows energy to pass through. I like my definition better. Insulator prevents or stops energy from going through. So here's a great picture you can label right here. 2 different parts of the wire from the toaster, and you should know what this is pointing to and what word goes here. It's either insulator or conductor, and you should know what word goes right here. Since it's pointing to the metal part, it's either insulator or conductor. So y'all can push pause and answer the question. Make sure everybody has it correct.